Measurement of physical quantities. In this lesson, today we will see the next part of our lesson, that yesterday we had seen the mass. Okay, what is mass? I told you. First we will revive in short. Just I told you so many quantities are there, things are there. For example, it may be the potatoes, tomatoes. We are weighing with the unit, we are using the kg unit. For some things are there, we are taking its volume, like milk, water. These are the liquids. Okay, so we are finding the volumes of liquid, then the weight of solids, and the density of various of substances, and for that purpose we are using the different units. These units are some are scalar quantities and the vector quantities. Scalar quantities, inside we are taking the only what the magnitude we are taking in account. What we are taking in account? Only magnitude we are taking in account, and that of the, and its examples are the such as length, breadth, area, mass, temperature, density, time, work. These are the things, these are the scalar quantities. Okay, and these scalar quantities are there. In this we are not taking account direction, we are taking only the magnitude only in its account. For example, 5 centimeter. Okay, 5 is the magnitude and cm is the unit. Okay, this otherwise breadth is equals to 90 meter, distance between two places is 100 kilometer. Okay, then afterwards time 5 o'clock. Then work, we are measuring inside, means what is the temperature, degree Celsius, inside 5 degrees Celsius. Okay, then we are saying that the length, what we are saying, mass, kg, 5 kg, 8 kg. In this way we are taking only the magnitude in account, and that's why these are the scalar quantities. And the next one is the vector quantities. What is vector quantities? Vector quantities where we are taking two things in account, and those are the magnitude and the direction. Okay, so magnitude and the direction. For example, see here, 20 kilometer towards the north. So here it is north is the direction. The aeroplane flying at a velocity of 500 kilometer per hour towards the Mumbai. So Mumbai's direction is shown inside it, and that's why these quantities are called as a vector quantities. These two things are there very important, that is scalar and vector quantities, that we are means we have to use continuously till you are studying the physics. Okay, and that's why you must know these things. This is the base of the higher classes, and this is the physics lesson, and the concept are little bit tough, but if you understand it, it will not means difficult for you. So you have to understand it properly. So next point we are looking, yesterday I told you what is mass, and mass, that I told you mass is a scalar quantity because direction we are not taking into account. And what is mass? Mass is a qualitative measure of the inertia of an object. That is one definition. And one more definition is the, what is the amount of matter present in a substance is called as a mass. Okay, this one is clear for you. Amount of matter present in a substance is called as a mass, and mass is a qualitative measure of the inertia of an object. As for that I told you, this is the 5 kgs. Suppose it is a weight 5 kgs, and if it is on the ground, it will remain at its position till we are not applying any kind of external pressure force on it, until that it is remain at its position. And that's why mass is called, here they told you, qualitative measure of inertia of an object. Means this, there is a tendency of an object to remain in its position is called as a inertia. Okay, and inertia's qualitative measure is called as a mass. Now here we will see the weight. So first of all we will understand what is weight, and then we will understand that what is the difference between weight and the mass. So weight, what is the measure, what we measure in grams? Tell me what we are measuring in grams. It may be gold, okay, which precious things are there, that otherwise you just take example of the 50 grams of what, sesame. Okay, then means these are the things, kilograms, potatoes, onions, okay, or grams inside also. Solid things are there that we are measuring inside the grams and kilograms. And is the mass, what I told you, the measures in grams and kilogram is mass and not weight. It is mass, it is not a weight. Okay, so you get confused. Mass means also what we are thinking, it is its weight only. When we are going to the market, what we are saying, give me 5 kgs of potatoes, suppose. So what we are thinking, 5 kgs weight potato means it is its 5 kgs weight only, and it is its mass also. So if it is like that, then it is what? It is wrong. And for understanding it, we have to study this point, the gravitational force. So what is the weight? 1 kg, 1 gram, okay, 1 kg, 1 gram, these are called as a mass. This is called as a mass. Okay, and what is weight? What is weight? As you know that everything, if you hold in your hand, it falls on the ground. Okay, you take anything, it falls on the ground. Same way, suppose 5 kgs potato is there. 5 kg potato is there. Other way, instead of potatoes, what we are taking, we will take it is a Jaggery's block of Jaggery. This is 5 kgs Jaggery's block is there. Okay, when I am holding it in my hand, what happens? It remains in my hand, but when I leave it, then what happens? It falls on the ground. Okay, then why it falls on the ground? The reason behind it is that only one thing, that is the gravitational force. What is the reason? Gravitational force. So here what they told to you, what we measure in grams, kilograms, that is the solid things we are measuring in the grams and kilograms, and these are the mass of that object, and it is not weight. Its weight, it is not there. So what is weight? The gravitational force that acts on the mass is called as its weight. Means this is the 5 kgs Jaggery's block is there, and on it how much gravitational force is acting. Okay, that is what happens, called as a gravitational force that acts on this mass is called as its weight. Okay, just I will tell you example. Suppose I will give you 1 kg of murmure. Okay, and murmure you know, no, otherwise any light thing I will give you, and in another 100 kgs of what I told you, iron rod I will give you. Instead of taking 1 kg murmure, you take here iron only. One iron rod I will give you. 1 kg iron rod I will give you, and 100 kg iron rod I will give you. Which is easy to lift? Yes, correct. 1 kg iron rod is there, we can lift it very easily. Yes, 1 kg iron rod is there, we can lift it very easily. But 100 kg iron rod, we cannot lift it very easily. We need more power for it. Okay, the reason behind it is that it's a weight. For example, 1 kg iron rod is there, its weight is less. That's why on 1 kg iron rod, less gravitational force is acting on it. Okay, and there is a less gravitational force, so we can lift it very easily. But 100 kg iron rod is there, or anything is there, we cannot pick it very easily. The reason behind it is that its weight is more. That's why there more gravitational force is acting on it, and that's why what happens, it is difficult to lift the 100 kgs iron rod or block very easily. That is because of its weight. The weight means the gravitational force which is acting on the subject. So the gravitational force by which the earth attracts the object towards itself is called as its weight. Clear now what they told you? The gravitational force by which the earth attracts an object towards its center is called as the weight of the object, and therefore weight is a vector quantity and it is different at different places. Do you remember in 5th standard, I think you have one example. One boy is there, they are asking to you question in use your brain power. They are asking to you, that boy is there, he took the 10 grams of gold on equator, 10 grams of gold on pole. That is the question. They told you he took the 10 grams of gold on the pole and he sell it on the equator. Then it is means that person will take that gold, because the reason behind it is that, as you know that our earth shape is how it is there, it is in that way. It is not exactly surrounding circle. It is slightly flattened towards its pole, and due to this the distance between the center and this place is little, and when you are buying the thing at that place, what happens, it is near to what, center of the circle. That's why 10 grams weight is there here. It will be, when we weigh the 10 gram weight at this place, that weight will be less at this place on equator, and the reason behind it is that the distance between the center of the circle and this point is more, and due to this here more gravitation force is there, and that's why weight is more. But this same thing if we weigh here, it is little bit, shows little bit difference, because here due to the distance there is a less gravitational force act on this 10 grams of gold that we are taken here. It may be less, 9.5 something it will be, and that's why what happens, that person will not take the gold from that person which is weighed at the pole. Okay, and that example is there, and that is where exactly we can, it will fit in this place. So here therefore weight is a vector quantity and it is different at different places. On equator, on pole, there is a different magnitudes are there for this weight. Now again use your brain powers question. Why would the weight of an object maximum at pole and minimum at the equator? Yes, just now I told you the example. That is, this is suppose the earth. I told you that this is the pole, and this distance between the pole and the center of the circle is less than that of the distance between the equators and the center of the circle. If you see here, the shape of earth is not exactly circular. It is which? It is flattened towards the what? Poles, and that's why this difference is shown, and that is the answer of it. The weight of object is maximum at pole because more gravitational force is there at that place, because of the distance between the what, center and the pole is less, and minimum at the equator. Okay, next, why is the weight of an object at high altitude is less than the weight at sea level? Same thing is there. Suppose this is our earth and here sea is there. Sea means what happens, there some little bit be, otherwise I will draw the, this is earth surface. This is earth surface, and this is, on this earth surface sea is there. This is sea suppose, and this is the mountain. Okay, and due to this what happens, this is the highest altitude. So when we buy the weight of the object, we weigh at this level, which at the sea level means this level, sea level, then there is the distance between the center of the circle and this sea level is less than that of the this distance is more, and that's why what happens, the gravitational force is what happens, less at that place. And just now we seen that what, the distance increases. See here, the gravitational force is less on it, and due to this what happens, the weight of the object at high altitude is less, because at this high altitude, okay, the higher altitude, this is sea level, it is what happens, the distance from the center of the circle to this top is increases, and due to this what happens, gravitational force goes on decreases as you go high in means go away from the sea level, and at sea level it is more because this place is near to the what, sea center of the earth. Will it possible to use the one and the same unit to measure the physical quantities such as mass, weight, distance, velocity, temperature? Okay, it is possible. If I will say I have 1 kg temperature, I have 1 kg velocity, one only unit if I will use, my weight is 1 kg. Okay, in this way, one unit if we will use, it is means we can identify? No. So that method is wrong method. Instead of this, what if we use the method that is for everything the different, we have to use the unit. So gram, kilogram we are using for mass, weight, distance we are measuring in the kilometer, meter, centimeter, velocity, okay, and the temperature that we are using the different quantities for measuring. Velocity means what, its unit is, velocity means what, displacement upon time, displacement, that is the displacement upon time, and displacement we are measuring in the meter and time we are measuring in the second. So velocity's unit is the meter per second, and temperature, as you know that we are measuring inside the degree Celsius. This velocity's unit is there, it is not, means this year it is not for you, next year it is there. So if you understand, if I will say 1 liter of milk, so I can clear that milk we are measuring in the liter. If I will say 1 kg of milk, then it is what we are thinking, how to measure these solid things we are measuring in the kg, and for it is better to use the different what units for different quantities. In everyday affairs we measure different physical quantities. As these physical quantities are different from each other, a specific unit is used to measure each quantity. What they told you, in everyday affair we will using different physical quantities, okay, like temperature, mass, liter, meter, kilometer, centimeter. These things are there we are using in our daily life. As these physical quantities are different from each other, okay, these are different, means distance is different from the weight, okay, weight is different from the solid liquids if it is there, means these are the different things. And for different thing, for distance we are using the unit kilometer, otherwise meters, kilometer, meter, centimeter. For weight is there, for it we are using kg, gram, kilogram, in that way. And milk is there suppose, so we are using the unit liter. So if we use the different physical units for different physical quantities, okay, then what happens, here they told you, as the physical quantities are different from each other, means distance is different from the weight, weight is means volume is different from the weight. So these are different, they are different from one another, okay. As they are different from one another, their unit should be different from one another. So therefore the specific unit is used to measure each quantity. Then distance we are measuring in the kilometer. Then for example weight is there, we are using kg, volume is there, we are using in liter, okay. With this we are using the different temperature is there, degree Celsius, velocity just means in that is meter per second, speed meter per second. In that way different units we are using for measuring it. Therefore here here they told you, therefore different units are used while measuring the different quantities. Now here what they told you, do you know our body has weight? Yes, we have weight. Suppose our body has weight, our body has weight, mass is there, but on that mass, how much mass is there on that mass, then how much gravitation force is applying, okay, that is what happens, called it's a weight. So we can means we can pick very easily the small child, okay, who is 5 to 10 kgs, but instead of that, as he grow up, his weight increases and it is difficult for mother to pick up very easily. Now our body has a weight because of gravitational force on the earth, and the gravitational force of the moon being less, so our weight will turn into to be less there, our mass however is the same for both the places, okay. That is the question they are asking. Just now we seen that, okay, gravitational force is there which acts on the body, it is 9.8, it is there gravitational force. So how the mass increases, on it the gravitational force also what happens, it increases. And due to this what happens, when our weight increases, the weight means what I told you, on that mass, okay, whatever is there on that mass, how much kg, how much gravitational force act, okay, is called as a weight. And as you know that the gravitational force of the moon is less than that of the gravitational force of the earth, and due to this what happens, earth's gravitational force is more than that of the moon, so your weight here is different. And on moon, if you weigh yourself on moon, then that time your weight is what happens, less than that of the weight on the earth. And reason behind it is that only one reason is there, and that reason is which, that is the gravitational force of the earth, okay. And as you know, go here on the surface of the earth, gravitational force is more, okay. And as you go, suppose you are here, this is our earth, and here if you weigh yourself, okay, it may be 40 kg something is there your weight. And same thing if you go to on the moon, and if you weigh yourself, it is different, it may be less than this, means it may be 39, 36 something is there gravitational force. It is unit is there. In further classes you are going to study how to find out this. And the reason behind it is that here your weight is more because on the earth gravitational force is more than that of the moon's gravitational force. So moon's gravitational force is, as you know that when you seen some videos which is share on the National Geography or other channels inside, so on it what happens, that they are telling, if we pick the thing we keeping as it is, it floats on the surface, but in the on the earth, if it something leave it, then it falls on the earth. Reason behind it is the earth gravitational force attract that thing towards its center, but the moon's gravitational force is less, it is not able to attract the thing. So whatever thing is there, it move, what happens, it moves around the moon. Okay, it is does not falling on the moon because its gravitational force is less than that of the gravitational force of the earth, and that's why your weight is less on the moon and that of the on the earth. Understood all of you? Now today we will stop here only. Next part of the lesson we will see in our next lecture, that is new point is the standardized measurement. So okay, have a good day.